Hello. So, in this video, we're going to be tackling the quotient rule, or what to do when we have a quotient of functions. So, as we've seen, right, the sum and difference rules for derivatives, they just go through without a hitch from the limit versions of these things. And the product rule was sort of close, but not necessarily sort of exactly what we would hope, but nonetheless, it was relatively nice. Quotient rule, this is what we're sort of tackling now, and it's what we're going to use when we have derivatives of functions that have quotients, right? The f of x over g of x. So as usual, we're going to start by looking at the difference quotient. So the difference quotient, it's a big thing here. So again, we can see, right, we have this f over g. So we have the x plus delta x bit that we put in the first part, and then this x part here. And over here, we're just sort of getting a common denominator and putting these things together. Now, remember that in order to be differentiable at a point, right, the function has to be continuous at that point. That's not sufficient, as we saw, but it is necessary. So we actually know the other direction, meaning that since we are wanting this thing to be differentiable, we know that f of x over g of x has to be continuous at that point. Otherwise, there's no point in talking about any of this. So in particular, since g of x being 0 would make f of x over g of x not continuous, it wouldn't be differentiable, so there's no point in talking about it, which means that we sort of can assume that g of x is not 0 at whatever point we're talking about. Otherwise, there's no sort of point of taking a derivative there in the first place. Okay, we're going to use this a little bit later, but just as a sort of footnote, right, we usually worry here that this delta x is going to be going to 0, and that's what's causing a problem. So you might also worry that like g of x is going to 0 might also cause a problem, but it turns out we don't have to worry about that. So we can go through the computation of the quotient rule here. So we start with the original difference quotient, which, right, we got the common denominator to get this form. Now, remember that we have this quotient law for limits as long as the limit is defined. But remember, right, we don't worry about the g of x being 0 like we just said. So that means that we can actually split this using that limit law for quotients, right? The limit part, not the derivative part. So I can split this apart. And this first part, right, because g of x itself is going to be continuous, otherwise I don't need to worry about any of this craziness. Right, because if it weren't continuous, it wouldn't be differentiable. So that means that I can just evaluate this first limit directly. So in particular, that first bit becomes, right, g of x times g of x, which I'm writing as 1 over g of x squared. So that's where this comes from. And then we're left with this piece on the right. So to go to the next step, we want to do that adding 0 cleverly bit. So I am adding and subtracting this f of x times g of x bit. Okay, and I put the subtraction first because I'm going to want to group these first pieces and group these second pieces, which is exactly what I do here. So I am regrouping these terms, right, these first two together and factoring out the common g of x. And I group together these second pieces, so this term and this term, and factor out that common f of x. So now I can split over that plus right here, right, using my limit laws. So I have this piece and this piece as separate limits. And remember that this delta x, right, my limit is in terms of delta x. So when I look at just g of x or just f of x, there's no delta involved. They're considered constant multiples. I can move them out. Right, so here I moved out the g of x from the limit because g of x doesn't depend on delta x in any way. I moved out the f of x from the limit because it doesn't depend on delta x in any way. But you also might notice that here I have g of x minus g of x plus delta x, and my difference quotient needs to be the other way around, right? Like this one, f of x plus delta x minus f of x. So I also have to factor out a negative to flip the order of those two terms, right? To make the part with the delta x positive and the part without it negative. So really I'm factoring out a negative f of x from that bottom piece. But now, if I look at what this is, I have, right, still my square, but then I have g of x times the difference quotient for f, so that's just f prime. And then I have negative f of x times the difference quotient for g, so that's negative f of x times g prime, right? So this gives me a sort of nice compact version of that difference quotient. Okay, so this gives me my chain rule, my quotient rule. So here I have the derivative of the quotient, right? Derivative of f of x over g of x. This thing is the g of x times f prime minus f of x times g prime of x all over g of x squared. Now, the thing is that this involves a quotient and a subtraction. Neither of those are commutative. So here, order really is important. You need some way of remembering exactly which term goes where. So the sort of classic mnemonic that a lot of students learn is this low d high, meaning low g of x times d high, the derivative of the top, f prime, minus high f of x d low g prime of x all over low g of x squared. Right, so low d high minus high d low all over low squared. This is sort of the classic mnemonic, but really whichever way you want to sort of remember it, however you want to remember it, the key is that where stuff goes matters. Now, I'm going to point out sort of a weird way of thinking about where everything is in here for sort of looking forward a little bit when we learn the chain rule, and it turns out there's another way of recovering this, and we'll talk about that in the future. But for now, I'm going to just sort of point out that this first term here, you can think of this as the first term, but you could also think of this as the positive term, right? The one that doesn't have the subtraction attached. This is the original denominator times the derivative of the numerator. And the second term, again, you can think of this as the negative term, the one that has the negative attached. This is just the numerator and the derivative of the denominator. So it is maybe helpful, or it will be helpful, to think that this negative is sort of attached to this pair of terms rather than thinking about sort of minus and then this term sort of on its own. Again, why we'll see a little bit in the future, but this is sort of a helpful observation to make at the moment. Okay, so what did we learn? So we tackled the quotient rule, and admittedly the algebra was a little intense, requires some clever manipulation, but the result now is that we have a, relatively speaking, compact sort of rule to handle quotients so that we don't have to go through the difference quotient in order to figure out what that's going to be, right? So now we can actually do derivatives of, taking the quotient of two terms, something like x over square root of x, or x over e to the x, or whatever. We could do these things with quotient rules rather than going through the difference quotient, right? So that is that.